Automated vehicles are a craze that seemingly won't die down. Even as companies close up shop, progress moves much more slowly than seemingly anyone projected. And even in the places where these vehicles are available to take you on a trip without a supervisory driver, the conditions have to be just perfect. No snow, ideally no rain, and lots of roads. We might have just found a way to make automated cars work by removing most of the humanity from the places that these things actually operate in. But, and this might surprise you, I do think automated vehicles are the future. Just not in the way that most tech companies or auto manufacturers would have you believe. Instead, I think automation is going to make the case for transit and human-centered mobility over cars just far more obvious, as the cost of transit shrinks and the relative cost of cars only grows. The issue is that automation just doesn't solve most of the problems that cars have. Well, it absolutely does fix most of the major issues that public transit faces, from the cost of building to frequency. So let's dive in and talk about the future of mobility, automated transit. Welcome to RM Transit, a channel where we talk about different mobility futures. Consider supporting the channel on Patreon to help me bring you more videos. Automated cars have always been a bit of a funny idea to me because they fix one big problem with driving, that is, the annoyance of driving, but barely address many of the other issues cars bring. Cars require tons of space, and even if automated cars don't need to spend as much time parked, they still need tons of road space so they can circulate around, deadheading from one trip to another. And roads are also just inherently very space hungry. An interchange between two highways requires a ton of ramps and interconnecting roads, while an interchange between two subway lines requires a comparatively skeletal amount of space, with two concrete boxes that can easily be excavated from the earth. And even on a straight and level road, trains use space far more effectively. Despite trains being wider than cars, a train track takes up less space than a road lane, because trains use rails, and those rails also mean far more efficiency because of less rolling resistance. They also mean less maintenance and lower costs and less emissions, which are critical things to consider for the longevity of a transportation system. And you can move more people along a rail line than on a road as well, because trains tend to be long coupled units as opposed to short independent ones that need to be spaced out for safety reasons, in case a tire goes flying or another vehicle cuts you off, even if it's an automated vehicle. The fundamental issue is that automated cars or not, cities built around transit are just far more efficient, because they solve mobility problems by not just scattering people's destinations and homes all across a city in a totally unstructured way. Putting your development, origins, and destinations nearer transit doesn't just make transit viable. It's more efficient, because when places are close together and connected by clearly defined corridors, you don't actually need to always rely on a vehicle. You can also walk or cycle. No amount of mobility innovation is going to solve space-agnostic, planning-free urban sprawl and poor land use. The biggest problem, though, is of course the fact that automated vehicles just aren't a proven thing. The edge cases are nearly infinite, the degrees of freedom are many, and the variability from place to place is huge. By comparison, we've had industrial-grade automated railways that are safer than traditional railways for decades. In fact, the safety of many automated train systems has been confirmed with mathematical proofs. You'll often hear people say that for automated cars to take off, they just need to be safer than human-driven cars. But if you want safety, trains blow both out of the water. While the number of cities with commercial automated vehicle services without humans to intervene can be counted on one hand, the number of cities with automated transit systems is enormous. These lines have been built in the desert, monsoon-prone tropics, and in the snowy conditions of Montreal. And they already move millions of people reliably every single day. There are automated train systems on every populated continent, and essentially every major city in the world already has some form of automated transit. If not a metro, then some sort of automated people mover that runs on these same underlying technologies. And even in the most car-centric places, like Atlanta or Dallas, when people really need to be moved around efficiently in a small space, like an airport terminal, there's still automated transit systems that are effectively subways. You don't hear them ringing up Elon Musk because automated transit just works. But it's not just flashy airport transit systems or brand new metros that are getting the automated treatment. Increasingly, older systems are being retrofitted for driverless operation. From Sydney to Paris and Copenhagen, one of the first cities to start automating its suburban rail system on top of its urban metro system. And we're just getting started. Now that automated technology is so well proven, there's entirely new ways of designing and planning systems that we can consider, like with smaller stations served by more frequent trains. while automated cars will require massive underground complexes with their swinging doors, complete lack of level boarding, and inefficient loading, which completely blows up the idea that automated cars are an affordable alternative to mass transit, which needs a diminutive space by comparison. Probably the first example of a system that truly feels like it's designed to take advantage of its lack of drivers is London's DLR, which has managed to be incrementally expanded over the decades. There are still staff on board every DLR train, but they aren't pushing a button and watching the train roll along. Instead, they're managing safety, helping customers, and checking tickets. At stations where few passengers will load or unload, you can even have a shorter platform with only some of the doors on the train opening. More of the network can be built single track, as a computerized central control system ensures that every train is where it needs to be when it needs to be there, keeping the whole thing running like clockwork. And all kinds of different service patterns can be operated with on-the-fly dispatching. So if a major event lets out, you can run more trains, and when it ticks over into rush hour, you can completely change your service patterns to match the demand pattern that people are pushing on your system. Or service patterns can be totally reworked when rush hour kicks into high gear. Honestly, with advances in LiDAR and radar created for automated cars, we'll probably even be able to automate railways with level crossings in the not-too-distant future. Suffice to say, automation will allow us to completely rethink how we plan and engineer rail systems. And we're still only in the early days of creating networks that will look completely different from the ones we have today. And truth be told, rail isn't even the most interesting possibility with automation. The suburban bus system of Toronto is in many ways the gold standard of public transit. Frequent service to almost the entire city on a regular basis, and all only for a few dollars. This model, while it's great, has two key problems. For one, buses are expensive to operate, and for two, they're chaotic to operate when you have thousands of them moving around your city. But with automation, and of course some bus lanes, these problems could be solved. Systems like Toronto's buses would be far more efficient with buses coming on time down to the minute. And they'd be super affordable to operate. So basically every city would be able to have a Toronto-style bus system that moves over 1 million people a day, but without having to 10x their transit operating costs. Now, you might ask, if you're going to do automated buses, then why not just do cars? But I'd flip the question around. If you're going to do automated cars, why not buses, which are industrial grade, designed to be used and abused, and last much longer than private vehicles? We've even solved problems like in-motion charging for buses that don't have clear solutions with private cars. And of course, buses are also an order of magnitude more accessible. You see, automation will transform mobility, not towards cars, but away from them. Thanks for watching.